Hello and welcome. Right now, we're going to look at why averages can be really, really annoying. So, the average Bachelor of Arts geography package in the University of North Carolina in the years 1985, 86, and 87 are as follows: $20,000 to 50K and 22K. You might wonder why in 86 it more than doubles. That's because of this individual right here. I think most of you know. So yeah, that's why we have a small problem with average because it tells us that the expected package for a geography graduate in that year, 86, bumps up to 250K, but it clearly doesn't because that's not realistic. The only reason that bumped up is because Michael Jordan, he had a very high salary package, right? From the NBA and stuff. He had a lot of brand deal sponsorships. So because of that, the class average went up and it went really up and it went to 250K. But we shouldn't expect 250K, right? Because it's not a realistic package. We have Jordan as the outlier, and that clearly has a very big impact. It gives too much weight to his own salary, which we can't expect from others typically. So, what do we do here? We use the median, right? Because, yeah, clearly the mean does not work for this place. What else can we do if we really want to stick to the average? In professional use cases, you're going to have to use the averages because medians are often very blind. They don't pick up enough information. We've discussed about underfitting and overfitting, right? How overfitting picks up too much information, underfitting picks up too less. In this case, we can look at the mean as the overfitting model and the median as the underfitting model because the median does not pick up as much information as the mean or the average. So in real world cases, we can use something called a trimmed mean, which basically means that we're going to cut off a certain percentage of our data points. So if we have a lot of outliers on both ends, we can cut off 5% from the top, 5% from the bottom. What that means is a majority of the outliers are going to be cut out. So now we have a more even distribution and we'll get a more promising or realistic mean. And suppose if we do not want to cut out the top 5%, top bottom percent, top 10, bottom 10%, we can use something called a Winsorized mean. In this method, we're going to replace all the outlier values or the unusual values with one of the expected values. So whatever typical value lies very close to the outlier. Okay, let's consider a use case where we have different speeds or rates with different weightages, right? So let's take two trips, all right? Right. So now we have two trips, one from the house to the office and one from the office to the house. Let's say the average speed was 30 kilometers per hour for the house to the office trip, and it was 60 for the office to the house trip. Okay. So you might say that the average speed is just going to be 30 plus 60 by 2, right? Because two trips, so it would be 45. But this is not the realistic expectation for average in this case because since we're traveling the same distance from the house to the office or the office to the house in a slower speed from the house to office transport, this means that we're spending more time here. So in this case, we're spending a bit more time compared to this case. This means that we have to give more weightage over here. Because of that, we cannot use the normal average calculation, and what we have to do is use the harmonic mean. What the harmonic mean does is it takes the reciprocal of both the values, adds it, and then averages it out. So now if we take the harmonic mean of this, we'll get 1 by 30 plus 1 by 60, which will be 3 by 60, and then we can decrease it to 1 by 20, and now we take the average of two trips. So 1 by 20 by 2, which means we'll get 1 by 40. Now again we take the reciprocal as the last step and we get 40 kilometers per hour as the average speed for these two trips over here from the house to the office and the office to the house. So since this 40 is not a typical value that you actually think about, and this is actually how you're supposed to calculate the rate or speed changes in different real life applications, just keep in mind that the base average calculation cannot be applied to every single use case. We have to tune our average calculation method based on what data we have, how much data we have, the percentage of outliers, how important are the outliers, how important is the sample space size, and all those factors as well. So I hope you understood how we have to be a bit more careful with averages while using them as a metric and how they change based on their application. So yeah, I hope you understood everything, and if you have any questions, just drop them below. I'll try to answer them. And yeah, thank you guys for watching. Curiosity is the only thing that's gotten us this far. I'll see you guys in the next one.